Okay, in the previous video, we did our first true example of constructing a confidence interval from beginning to end. Now, one tricky part of this is you need to know which formula to use. Because when you look at our statistical flowchart, you see I've got several different, at least 4 different confidence interval formulas. So which one do we use? Well, you got to know which test we're doing. In this first section, we're doing proportion tests. How do you know it's a proportion test? The way you know it's a proportion test is because we're looking at percentages of people. You know, you either get the side effect or you don't. It's kind of similar to a binomial. You either get the side effect or you don't. Or the person is either going to vote for you or they're not going to vote for you. If you're doing dividing the number of people divided by a sample size and getting a percentage or a proportion, that's when you know you're doing the proportion formula right here with a p hat and a q hat. Paired data we'll look at in a future section. That's a before and after kind of thing. And the final one are the mean confidence intervals. That's where you're actually looking at an average of something. Like you weigh 1,000 cows and you see what the average weight of the cow was. That's not an either or question, that's an average question. But you'll notice, look how similar these 4 formulas are. They're all the point estimate minus margin of error, less than the population parameter, less than point estimate plus the margin of error. All 4 of these are basically the same formula, you just get the values in a slightly different way. So don't feel overwhelmed. Just because we learned this one formula, we've kind of learned all 4 of these already, and I'm going to walk you through all of them one at a time. Okay, so let's look at the next example. Page 2. A clinical trial tests a method designed to increase the probability of conceiving a girl. In the study, we had 340 babies, and 289 of them were girls. Use this data to construct a 99% confidence interval. All right, does the method appear to be effective? That's it. We only need to know 3 numbers, and we can construct the entire confidence interval. Now, is this an example of a proportion confidence interval? The answer is yes, because it's a yes or no question. We had 340 babies, 289 of them were girls, so we can divide this number divided by this number to get a proportion. It's like either or. It's either a girl or it's not a girl. And so we can use a proportion confidence interval to do this. So let's write down what that formula is. I am constructing a confidence interval. You start on this bubble. We just answered the question, is it a proportion? Here's the formula right here. So the formula is p hat minus z alpha over 2 times the square root of, let's see, p hat q hat over n is less than p is less than p hat minus z alpha over 2 times the square root of p hat q hat over n. All right, there's our formula for constructing our confidence interval. And I know it's a little bit hard to read my handwriting, so all I did was I just copied the proportion confidence interval from section 7.1 from the flowchart. So that's all I did there. So that's it. Let's go ahead and plug in our numbers. So first let's figure out what our numbers are. We need to know what p hat is, q hat, n, and z alpha over 2. Let's figure out those 4 numbers. We'll plug them into the formula and then we'll be done. Okay, how do we get p hat? P hat is your proportion from your sample. It's called the best point estimate. We get that by just doing 289 divided by 340. Okay, so all you got to do is just 289 divided by 340, and that will give us p hat. And that's exactly 0.85. That's nice. Okay, q hat. Q hat is equal to 1 minus p hat So if I do 1 minus 0.85, we see that it's 0.15. Think of this as the probability of having a girl and the probability of having a boy with this method. N is easy. N is our sample, 340. And Z alpha over 2 is our critical value. The more confident we are that our confidence interval contains the true value, the bigger this number gets because we have more standard deviations, which means that our confidence interval is less useful because it's bigger. We don't want a big confidence interval, we want a tight confidence interval. So it's a trade-off of how big it is versus how likely it is that our confidence interval contains the true value. So let's find Z alpha over 2. We have a 99% confidence interval, so we go down to this little table that I made for us. Sorry. So all confidence intervals are two-tail. So two-tail confidence interval, 99%. Remember, we said it was a 99% confidence interval. So we come to the table, two-tail confidence level, 99%. Our number is 2.576. That's it. Those are all of our special numbers. Now it's just a matter of plugging all of these numbers into the formula and getting the right answer. So to write this all down, it's 0.85 minus 2.576 times the square root of 0.85 times 0.15 divided by 340, less than p, less than 0.85. Oops, I made a mistake. This should be a plus. It's p hat minus stuff, p hat plus stuff. So sorry about that. Maybe you even caught that. So 0.85 plus 2.576 times the square root of 0.85 times 0.15 over 340. All right, so take a look at that. I think I'm going to upload all these notes so that you can follow them as I do them. But there you go. Now it's just a matter of throwing this into our calculator. One thing you might notice is that this number is the same as this number. And remember that that's because it's our margin of error. So it might be easier to just calculate the margin of error and then do 0.85 minus it and then 0.85 plus it. In fact, that's what I'm going to do, just to put less in my calculator. So I'm going to do, I like doing the square root first and then working backwards, or this time I'm going to show you how to do it plugging it all in. Again, I don't recommend doing this unless you're very careful, because it's easy to make a mistake when you're doing this. So 2.576 times the square root of 0.85 times 0.15 divided by 340. So that number right there is our margin of error. Okay, that's just this piece of it. So what I'm going to do now is I'm going to do the left side, so 0.85 minus that number, 0.85 minus the number. In fact, another way of doing it is on my calculator I can just move up and then just hit enter. So what I can do is I can do 0.85 minus that number. And on this side, I will get 0.800 is less than p is less than. Now I do 0.85. We're going to do the right side now. So 0.85 plus, and I just move up in my history, 0.85 plus that number, and I get 0.89988. And so I'm going to round that up to 0.900. And indeed, this is the correct answer. Okay? And so that's how you do it. Or you can just throw the whole thing in your calculator each time. That's perfectly good too. So, from this method, 85% of the babies were born as girls. And if we do a confidence interval to say, okay, well, how likely is it that the true universe proportion for this method, we're 99% sure that this confidence interval of 0.80 to 0.90 captured it. And so what that means is, does the method appear to be effective? Here's how you could tell the method is effective. If the entire confidence interval is above 50% or below 50%, then you can say something about it. But if the confidence interval contains 50%, then that means you're not sure what it does. The method may be effective, it may be not effective, it may be even reverse effective for all you know. However, notice how this whole confidence interval is far above 50%. 50% is not in the confidence interval, and so because that, we can say that the confidence interval does appear to be effective. Okay, so that's your measure of whether or not a proportion confidence interval is effective, is whether or not it contains that critical 50% value. Think about if you were running for office and I said 51% of people in my survey said they'd vote for you, but the confidence interval is 47 to 55. Well, that's no good because 47 is just as likely as 55, so I haven't told you whether or not you're going to win. We would need to get more data to determine it. All right. Hopefully seeing a second example has made this not feel so scary. Please let me know if you have a question by emailing me. And I know this method isn't ideal, but we'll keep charging ahead, and hopefully I will be able to answer all your questions. I will see you in the next video.